Hello, today we will talk about the topics of limits in calculus. The purpose of limits is to examine the tendency of a function around a given point even when the function is not defined at the point. Definitions of limits. In mathematics, a limit is the value that a function approaches as the input approaches the same value. Limits are essential to calculus and are used to define continuity, derivative, and integrals. The limits of function written as limit function of x approaches a. What is tangent line and secant line? A line is called tangent to a circle if it meets the circle at precisely one point, referring to the graph. Imagine there is a circle on the curve in this graph. This is called tangent line because it met the circle precisely at one point, while P and Q is a secant line. If Q moves towards P, the secant line moves towards a limit position. Therefore, the line in limit position is called tangent line at point P. Concept of approaches. Limit function of x when x approaches a equal to L. It means that the value of fx can be made as close as we like to L by taking the value of x sufficiently close to a but not equal to a. Left-hand and right-hand limits. The limits when x approaches a from left, when the value of x is less than a, it is known as left-hand limits. However, for right-hand limits, the limits when x approaches a from right, the value of x is greater than a. How do we know the given function is left-hand or right-hand limits? The superscript of negative sign on the approaches value indicates a limit from the left, and the superscript of positive signs indicates a limit from the right. The limits of function fx when x approaches a equal to L exists if and only if the limit of function fx from the left-hand side is equal to the limits of the function of fx on the right-hand side. If the left-hand limit is equal to right-hand limits, it is two-side limit. However, if left side limit is not equal to right side limits, it is one side limit. For your information, every two sides limits, the limits of function fx is exist. Prove that the following function is two-side limits, giving function fx equal to x squared minus 2x plus 3 when x approaches 3. From the function above, we come up with left-hand limits and right-hand limits. Substitute the approaches value 3 into the following equation. Hence, the limits of function fx when x approaches to 3 is exist and is equal to 6. The graph of the function is shown in next slide. The graph showing that the limit functions fx when x approaches to 3 is equal to 6 for both left-hand limits and right-hand limits. Is the following functions two-side limits? In this question, you need to consider the value of x. If the value of x is less than 0, it is left side limits. However, if the value of x is greater than 0, it is a right side limit. Hence, the limits of both functions when x approaches 0 is equal to -1 at left-hand and right-hand limits. So, it is two-side limit. One-side limits occur when the left-hand limit is not equal to the right-hand limit. Refer to the following example. Giving functions limits absolute value of x divided by x when x approaches 0. As x approaches 0 from the right, the value of fx approaches a limit of 1. In fact, the value of fx are exactly 1 for all such x. And similarly, as x approaches 0 from the left, the value of fx approaches a limit of -1. Substitute the value of x. The function of fx from left-hand limits is not equal to right-hand limits. Therefore, fx is one-side limit. Always remember that an absolute value of a number is always positive. Continue with one-side limits. Giving functions limits square root of 9 minus x squared when x approaches 3. From left-hand limits, substitute 3 into the function. The answer equal to 0. For the right-hand limit, it is undefined. Therefore, it is a one-side limit because the left-hand limit is not equal to the right-hand limit. Note that the value of x of a square root must be always greater or equal to 0. Therefore, in this question, the value of x in the 9 minus x squared must be greater or equal to 0. What is infinite limits? Infinite limits occur when one-side or two-side limits fail to exist because the value of the function increase or decrease without bound. Giving the following function limits 1 over x when x approaches to 0. For right-hand limits, the value of function is a positive infinite. In this case, 0 is very close to 0, but it is not 0 or can say a smaller number. From right-hand limits, it is a negative infinite. It is same case, but from left side, that means it's negative number. From the graph, we can see that when x is closer and closer to 0 from the right, the value of function 1 over x are positive and increase without bound. However, when x is closer and closer to 0 from the left, the value of function 1 over x are negative and decrease without bound. For your information, the symbol of positive infinites and negative infinites here are not real numbers. They simply describe particular ways in which the limits fail to exist. Do not make mistake of manipulating these symbols using rules of algebra. For example, it is incorrect to write positive infinite minus positive infinite equal to 0. Continue with infinite limits. Giving function limits 9 over x minus 2 when x approaches 2. In this function, the value of function equal to positive infinite for the right-hand limit, and it is a negative infinite for the left-hand limit. Limit also does not exist if the function does not approach a particular value or is called oscillation. Giving example, limits sin 1 over x when x approaches 0 for the right-hand limit. This function does not exist. The graph reveals that the value of f oscillates between -1 and 1 with increasing rapidity as x approaches to 0 and hence do not approach a limit. Next, we will discuss about the technique of computing limits of any function. Let's look at the properties of limits. If function of c is a constant function, the value of fx remains fixed at c as x varies, which explains why functions approaches c as x approaches a for all value of a. Let's look at the example. Next, the limits of function x to the power of n when x approaches a is equal to a to the power of n. Refer to the following example. The approaches value will be remain and carry on the exponent value. Next, the properties of limits. Limits k function of fx when x approaches n is equal to k limits of fx when x approaches to n. Example 1. Giving functions limits 9 open bracket x squared plus 2x plus 1 close brackets when x approaches to 3. First, rearrange the giving function according to the properties of limits. Substitute 3 into the following function and the answer is 144. Example 2. Giving functions limits 6x plus 2 divided by x plus 1 when x approaches 1. From here, we can see that the numerator can be divided by 2. Rearrange the giving function according to the properties of limits. Substitute 1 into the following function. Then we get the answer of 4. Continue with properties of limits. There is also the law of limits of the sum, difference, products, and equations of functions. The limits of a sum or difference is the sum or difference of the limits. Example 1. Limit 3x plus square root of x plus 5 when x approaches to -4. First, separate the function of fx and gx according to the properties of limits. Substitute -4 into the function and the answer is -11. Example 2. Given functions limit 5x plus 3x squared when x approaches 2. Separate the function of fx and gx according to the example 1. Substitute 2 into the function and the answer is 22. Next, the limits of a product is the product of the limits. Referring to the following example, giving functions limits x cubed times 1 plus x squared when x approaches -1. First, separate the function of fx and gx according to the properties of limits. Substitute -1 into the function and the answer is -2. Example 2. Given functions limits 3x squared divided by x squared plus 1 times 2x cubed divided by x cubed plus x when x approach to infinity. Separate the function of fx and gx as example 1. Substitute the infinity into the function. The answer is 6. Next, the properties of limits. The limit of a question is the questions of the limits, provided the limit of the denominator is not equal to 0. Refer to example 1. Giving functions limits x squared plus 3 divided by x minus 1 when x approaches 3. First, determine x squared plus 3 as numerator while x minus 1 as denominator. Substitute 3 into the function and the answer is 6. Example 2. Giving functions limits square root of 2x minus 4 divided by absolute value 1 minus x when x approaches to 10. Same as example 1, determine the function of fx as numerator and gx as denominator. Substitute 10 into the function and the answer is 4/9. Next, the limits of a square root or nth root is the square root or n root of the limit provided the limit is greater than 0 if n is even. Referring to example 1, giving functions limits square root of x squared plus x plus 1 when x approaches 3. Substitute 3 into the function and the answer is square root of 13. Example 2. Giving functions limits square root of x cubed plus 1 when 1 approaches to 1. Substitute the function according to the properties of limits. Substitute 1 into the following functions and the answer is square root of 2. Limits of polynomials and rational functions. Polynomial is an expression consisting of variables, also called indeterminates, and coefficients, that involves only the operation of addition, subtraction, multiplication, and non-negative integer exponents of variables. Rational function is any function which can be written as the ratio of two polynomial functions, where the polynomials in the denominator is not equal to 0. Example 1. Given functions limits x to the power of 3 plus 2x plus x plus 1 when x approaches 3. Substitute 3 into the function and the answer is 37. Example 2. Given functions limits x squared plus 2x plus 1 divided by x squared minus 1 when x approaches 3. Substitute 3 into the function and the answer is 2. Continue with limits of polynomials and rational function. Given function. First, expand the numerator and denominator to an algebra expression. Next, cancel the same numerator and denominator. Substitute approaches value of 4 into the function and the answer is 1 over 2. Let's go to the next example. Giving functions. Divide the numerator and denominator with x squared. Cancel the same numerator and denominator. Substitute infinity into the function. Here we assume 0 as infinity and the answer is 1 over 2. Limits involving radicals. A radical is a symbol of the indicated roots of number, for example, a square root, cube root, or nth root. Example 1. Giving function by using conjugate. Conjugate is a form by changing the sign between two terms in a binomial. In these questions, the denominator square root of x minus 1 is a radical. Therefore, we're using conjugate to get rid of the square root. Cancel out the same numerator and denominator. Substitute 1 into the function of x and the answer is 2. The next example, giving functions. Here we can see that 1 minus square root of 6 minus x is radicals. By using conjugate as example 1 to get rid of the square roots. Cancel out the same numerator and denominator. Substitute 2 into the function of x and the answer is equal to 3. Limits of piecewise defined function. For functions that are defined piecewise, a two-side limit at a point where the formula change is best obtained by first finding the one-side limit at that point. Or we can say that a piecewise function is a function that built from piece of different functions over different intervals. Given the following function, find the value of left-hand and right-hand limits as the following functions. Limit as x approaches 3 of x and thus the function exists. Determine the step two-side limit by first considering the corresponding one-side limit. For each side limit, we must use that part of the formula that is applicable on the interval over which x varies. From the three functions above, minus x minus 5 is not corresponding because the value of x is less than and equal to 0, while 2x minus 6 is considered as left-hand limits and x squared minus 9 is right-hand limits. Substitute 3 into both functions of x. Since both value of fx from left-hand and right-hand limits are equal to 0, Therefore, the limits of fx is exist. Continue with piecewise defined function. Given the following function, find the value of left-hand and right-hand limits when limits function of fx when x approaches 0 and does the function exist? Determine the state two-side limits by first considering the corresponding one-side limits as previous example. From the three functions above, x squared minus 9 is not corresponding because the value of x is greater than 3, while negative x minus 5 considered as left-hand limit and 2x minus 6 as right-hand limits. Substitute 0 into both functions of x. Since the value of fx of left-hand limits is not equal to right-hand limits, therefore, limits of function fx does not exist. L'Hospital rules and indeterminate form. L'Hospital rules provide a technique to evaluate limits of indeterminate form, for example 0 over 0 or infinite over infinite. The formula of L'Hospital rules is limit fx over gx when x approaches a is equal to limit f prime of x over g prime of x when x approaches to a, where f prime and g prime are the derivative of f and g. This derivative will allow one to perform algebraic simplification and eventually evaluate the limits. Note that this rule does not apply to expressions infinity over 0, 1 over 0, and so on. L'Hospital rules and indeterminate form. For the example below, we cannot simply substitute the approaches value into the function. This is because the answer will be in indeterminate form, either 0 over 0 or infinite over infinite. Therefore, L'Hospital rules was applied in this following example. The following are rules of differentiation. First example, giving function. By using L'Hospital rules, differentiate the numerator and denominator. Substitute 4 into the function of x. The answer is 1 over 2. Second example, giving following function. Differentiate the numerator and denominator by using L'Hospital rules. Differentiate the numerator and denominator for the second time. Substitute infinity into the function of x, and the answer is 0. Third example, giving function. Differentiate the following function by using L'Hospital rules. Cos 0 is equal to 1, and the final answer is 7 over 4. Continue with L'Hospital rules and indeterminate form. The following are the rules of differentiations. Fourth example, given function. Differentiate the numerator and denominator by using L'Hospital rules. Substitute 0 into the function. Cos 0 is equal to 1, and the final answer is 8 over 3. Fifth example, given function. First, let y equal to the function. Next, introduce ln in the function of y. Ln is actually a logarithm with the base of e. E is a concept number with the value of 2.7182 something. Next, bring the exponent value 1 over x to the front. Differentiate by using L'Hospital rules. Substitute 0 into the function. Ln y is equal to -2. Y equal to e to the power of -2. Express y equal to e to the power of -2 with a positive exponent using a minus n equal to 1 over a to the power of n. Therefore, the answer is 1 over e exponent 2. Various types of limits at infinity. Example 1. Limits 1 over x when x approaches to negative infinity equal to 0, and limits 1 over x when x approaches to positive infinity equal to 0. When x approaching to 0, the value of y will keep increasing and become infinity, while when x approaching to negative infinity, y is approaching to 0 but not equal to 0. Example 2. Limits tangent -1x when x approaches to negative infinity equal to -pi/2, and limits tangent -1x when x approaches to positive infinity equal to pi/2. The line y equal to pi/2 is a horizontal asymptote of f in the positive direction, and the line y equal to -pi/2 is horizontal asymptote in the negative direction. A horizontal asymptote of a function is a horizontal line that the graph of the function approaches as x approaches infinity or negative infinity. Note that a function can sometimes cross an asymptote. The way this function crosses the horizontal asymptote in the middle section. Example 3. Limits open bracket 1 plus 1 over x close brackets exponent x when x approaches positive infinity or negative infinity is both equal to e. E is a concept number with the value of 2.7182 something. When x approaches to positive infinity, the value of y will getting closer to e. Example 4. Limits e exponent x when x approaches negative infinity equal to 0, and limits ln x when x approaches 0 from the right equal to negative infinity. From this graph, we can see that the function of e exponent x is reflected on the line t from function ln x. The function e exponent x and ln x both increase without bound as x approaches infinity. Example 5. Limits e exponent -x when x approaches positive infinity equal to 0, and limits e exponent -x when x approaches negative infinity equal to positive infinity. The graph of function e exponent -x is the reflection about the y-axis of the graph function e exponent x. When x approaching negative infinity, the value of function f(x) will keep increasing to positive infinity. Thank you for watching. Bye.